Yeah. And so, all right. And so, here we go. Do I have rectangles? All right. Let's say you have your computer here, right? You have your little like computer that's like, and then it says, here is, I'm connecting to the internet. I'm like, the internet. And so then it goes to, the first thing it does is it goes to your ISP. This is your ISP. This can be like Comcast or what are some of the other ISPs? I can't remember. Like Warner Brothers, AOL, like who knows? So it goes to your ISP server, and it's like, and so the internet service provider, ISP stands for internet service provider. This is like what gives you the internet and what you pay like monthly for, and then you're just like, why am I bleeding money for like 5 megabits upload? Come on, I want something faster. And so this is the ISP. And so what it does then says, all right, so you're saying, I'm gonna search for www.instafluff.tv, right? You're like, tell me where Instafluff.tv is, and I want to search for it on my web browser. And you open up Chrome, and you're like, and so here's what happens. Then the ISP has these things, well, generally either here or some other provider, what's called a DNS server, like domain name service. I don't know if I need to write that down, but the DNS is, well, actually they usually have these as kind of like separate, and so they'll look it up, and then the ISP will probably just cache it on there. But the DNS servers are basically a list of server, or like they're just basically a giant database that says these are the domains, and then these are the IP addresses for those servers. So this would be like here's a giant cloud of I did the pencil. The cloud. Wait, here. The cloud, right? This is what we call the cloud. This is the rest of the internet. These are the Amazon servers, the Azure Microsoft servers, the Google servers. These are like someone's mom and pop server that's running out of their home from their ISP. Like this is the cloud. This is like all the different IP addresses. This can be like 65.2.47.4, like 42, like etc. Like those are the random servers. There's a whole bunch of them out there. Like these, and these, and we call that the cloud. And so basically the DNS server says, okay, like Instafluff.tv goes to here. I can probably just show you. Right. So if I do ping www.instafluff.tv, then all right, it pings. Oh, come on. It did it in IPv7. Okay, this is IPv6. This is the new version of the IP address. It used to be like the 6527, etc. But now they're switching over because this has a limitation of 100 million devices or something, and we've kind of like gone past that at this point with all the IoT, Internet of Things stuff. And Sparky, how are you doing? Happy Friday. Wednesday. I'm explaining how the internet works. This is how the internet works, everyone. If anyone was interested, now you know. And so the DNS server doesn't talk to like this our server. It's just like literally it's just a database. It just says like, okay, here's our whole entire giant like list of what these domains correspond to for all of the servers. And this is huge. This goes to all like the millions and billions of different like IP addresses and servers with the domains and subdomains and everything. Like that's what the DNS server does. It's not like one server, but like you can think about it as a server. Hi Khaled, how are you doing? Happy Wednesday. And so then here's what happens. Then the ISP says, okay, and so it gets a thing from the DNS server and then gets it back and says, all right. So what you're trying to do now is you're trying to navigate to Instafluff.tv. Well, that corresponds to 6527 So then it says, all right, well, your web browser should go to 125.3.42. But the thing is, when it does it, somehow when we designed the internet and the web browsers, the gods of the internet decided, all right, well, the normal port that everybody is going to talk to for the internet whenever we put this stuff on there is going to be port 80. That's like when you do http://www, then it goes to port 80, and so we hide it, and so that's why we can just type in www.instafluff.tv instead of www.instafluff.tv:80. But if you put in like :8889, then that's like one of the other ports that server has open. But instead, on general, it's port 80. But if you do HTTPS, which if the server happens to have that SSL support, the security support on it, then it talks to 443. And so we're saying, all right, this is HTTPS, right? So we're gonna say, all right, we actually want to go to HTTPS. So then we say, okay, now let me talk to, and then now you're talking directly to the server, and that says, and this could be just like the gateway server, as in like this could be just this server could just be the front end server that then redirects you to a bunch of other services or APIs or other web pages, or it could just be the one like single server itself. But this is what it talks to, and then says, all right, here's a web page and here's information. But before that, because it's an HTTPS thing, then it's gonna do this whole SSL certificate thing. And so this is like the what is it, secure socket layer, I think that's what it stands for. SSL basically then means that because it's a 443 thing, it's going to then talk to another giant thing called the what was it? CLA? No. CLS? Where is it? Certificate CA. Certificate Trusted TCA. Trusted CA. So this would be one of them. But then what it's gonna do is gonna be like, all right. I want to talk to this server, Instafluff.tv, etc., and I'm trying to talk to it on a secure socket. And so, is it secured? And then it says, okay, well, this is the certificate. This is the encryption key that you should be able to use to talk to the server. And so this is what you should expect. And so if you're not getting this same certificate back from the server, then you should not trust it at all, because that's very suspicious, and that means the DNS is pointing to some other random server that could be a hacker. And so that's what the SSC, that's the security part when you put in HTTPS. The S part of it means that you're going to some sort of trusted authority that tells you, we verified that this server is legit, and that this is the certificate that you're supposed to be communicating with them with. And so that means that anybody else, like all of the communication that happens over here then becomes locked. Like, is there a lock icon? I don't know if there's a lock icon. I'm gonna try and draw it here. All right, so now we use the trusted security certificate thing, and when they say certificate, the certificate itself is like a whole bunch of just random letters and numbers. It's like ASCII letters, and it'll be, I don't know, 1024 bit, 512 bit. It could be 2048 bit. It'll be something really just like a long list of just characters, and then it uses that as the encryption kind of algorithm in the basic sense, without going into the actual certificate and encryption stuff. And so it uses that and then says, all right, this is what it's going to be to talk to it, and every little packet that gets sent out from your browser to the server and back will be encrypted and decrypted using this. And so that's why it's really secure, because generally when you try and talk to the server, it also means, because it'll actually go through the ISP and stuff, right? So this also means that this will also generally go through other channels and hops. And so sometimes you can't just connect directly to the server. There might be other servers and relays and things, and like there might be relays or other ISPs, or there might be who knows, there might be other, what is it called, other data center things, or other gateways, etc. And so there might be a whole bunch of other things like this that happen that make this hop, and every time it does that will contribute to your latency, which is how fast your packets go and deliver, because every hop will add 30 to 50 milliseconds or so. And so because of that, that's why when you're generally like when you're playing a multiplayer video game like League of Legends and something, and when they're actually regionally like completely far away, then you're actually having to go through these other relays and whatnot to actually get to the server that you want, which will go through like ISP to this. And that's when you go from like, oh, I have 10 milliseconds of latency, this is great, I can be like the fastest and I can do all my like ultimate moves and everything really quickly, and then all of a sudden I move to Boston and I'm like, no, I can't play League anymore because now I have 120 milliseconds of ping. And that's because of this right there. And Desabotage and Hi Pizza Wizard, how are you doing? Happy Wednesday. So it's a relay, not the distance, that causes lag. Yep. I mean, there is like a little bit of that, just the distance that can cause it just physically because of just like the speed of signals going across the wire, but that's very, very insignificant versus like some other computer that has to reroute your packets to the other packets and then back and forth. And so that's why that's really, really like that gets to be much slower. Otherwise it maybe add what, like 1 millisecond time. And this is also why like a lot of like the finance things and like high frequency trading servers and things like those tend to actually be also geographically very, very close to New York or wherever the exchanges are. It's because they need to get it like as fast as possible. They need to be like, I need to get the latest data and latest prices in like half a millisecond. And so this boredom program ASMR. Oh, is it? Oh, that's good. Are you a double? I always thought it floats inside. That's so funny, Colin. Oh gosh. Oh, thank you, Pizza Wizard. Yeah, we're just kind of going through the internet for anybody that doesn't wants to know about how the internet works. This is how it works. And so this is where we're at. And so we have relays and everything and the certificates. And so the reason for the certificate is because the DNS server, this is called the DNS attack, right? It's like if you reroute it and say, okay, we're gonna replace what the DNS server is and pretend it to be something completely different, then you're just all of a sudden being like, okay, I'm pointed to a completely different thing. And so here's something else that people might not know. Every computer generally nowadays has a file called the host file, which acts as kind of like your own local DNS. Like if you want, and that's if you want to host your own like servers or your own internet or whatnot too, and the ISP generally does this for you, but your own computer, you can override these settings and be like, all right, maybe you don't want to check the ISP for the DNS server because you already know where it is, or you want to just like manually point it to the server because that way it's much faster and you can just like start talking to it directly and whatnot. So then you have it's literally just called a host file on, at least on Linux and Macs. And so you edit it and you're just like, all right, instafluff.tv and then space the IP address, and that's it. And then it'll always look there first before checking to see the ISP and check it from the server, because that means like you're doing a web request to actually get it all back. Fancy Yellow, thank you so much for the follow. And so you have this whole thing, and the DNS attack can literally be something like you download a virus that just replaces your host file on your computer with that number. And that's why localhost associates with 127. Let's see if that one. Yeah. Do that's an education stream? Not generally, but I just got onto this just like random rant about the internet. And so yeah, this is what happened. Are we coding today? Probably. Happy, how are you doing? Happy Wednesday. Happy Wednesday. And so, yep. And so there's all these like random things like 443. So then here's a whole bunch of other random things that like there's a bunch of other details to this, right? Also like the way that the IP packets are designed. There's like IP packets have like there's like, it basically works kind of like opcodes on your CPU. It's like, here's the IP packet, here's what type of packet it is, and here's what encryption, and then here's the actual packet, and then here's like the numbering of the packets, and then you can put another layer on top of it that says like, here's what it needs to work with. And then the whole idea behind like TCP versus UDP is also very different. Like TCP is, what is it? Something protocol, transfer something protocol. And so TCP means that you actually have a three-way handshake that says you send the packet, and then well, no, I think it actually goes like you initiate the communication. You say, okay, I'm going to send you a packet, and then the server says, okay, send me a packet, I'm ready. And then it says, okay, I sent you a packet, did you receive it? And it says, okay, I received it. And then you get confirmation back, and then it's like, okay, and yeah, but then UDP is the other way around. UDP is kind of meant for like video streams where you don't care, it's like time sensitive, or you don't care if like all of the packets arrive and you're just like throwing it out there. We don't have to do this whole handshake thing and make sure that like your actual data, every single packet gets there. So then you just kind of like throw it out into the void, hoping that it gets there. And generally you can turn that into TCP. That's kind of how it works. That was actually one of the networks projects that I had to do for class a long time ago. I was like, how do you build TCP on top of UDP? And so networks is really interesting, but really it feels like because of all of this, it gets to be fragile. But then I'm gonna show you why it's even more fragile. We talk about this as being the internet, and it's still very abstract. This is the internet. This is like your ISP, internet service provider, and the DNS, and any of these can be broken, and your ISP goes down, and all of a sudden everything's down. The trusted CA sources, if those go down, then you're like, okay, well, I can't talk to anybody securely anymore. Any of these servers other go down, then you're just like, well, what happens now? And also usually when we talk to these servers, then you get other things like Cloudflare will have other things where they act as the gateway, where they say, hey, we might get a whole bunch of people trying to do this, like DDoS. DDoS stands for, what was it? Like distributed denial of service attack. And so basically they just take a whole bunch of machines and they send requests to this one server and take it down, because then they get overloaded and they're like, I don't know how to handle so many traffic things at the same time. And so Cloudflare acts as like the DDoS protection kind of stuff for you on top of your server, so that it can be like, all right, we will act as the bodyguard for those kind of attacks, and we'll track where they're coming from and if they're doing it repeatedly, and so then they won't be able to break down your server. And so that happens. But then when Cloudflare itself goes down, then all of a sudden you're just like, well, I have no internet because all the websites are down on all of it. Or Netlify goes down, and you're like, well, now no one has access to every website that's hidden behind Netlify's servers. And so because of that, there's like so many random places where if like one point of contact just goes down, everything goes down. That's not good. According to Instafluff. Yep. Hi Povo, how's it going? All right, and so code in progress. Hello, happy Wednesday. Here's the other thing that makes this even crazier. I'm gonna try and draw the Earth and these back channels and things. So here's what is it like? Here's North America and South America, and then here's Europe and and Africa and and Asia. All right, and then here's like the North Pole. Here's where Santa lives, and so you're like NA, SA, and Europe, and Africa, and Asia, and so, okay, when we talk about the internet, we talk about all the servers and just like as a thing, right? Here's like, oh, here's the internet and everyone's connected, and like everyone must be just like super connected everywhere. Oh, this is great, right? It's like, oh, wow, like everyone's super connected, so if anything goes down, that's no problem. That's not actually how the internet really works, because there's this like giant thousands of miles of ocean and all the way around and everywhere. That makes things a little difficult to try and like send a whole bunch of data across all of the continents and get it to everywhere as fast as possible. And so what we have literally as a backbone of the internet is we have this giant like pipeline. We literally have a giant cable pipeline underneath in the ocean that goes from North America to Europe, and then like here it connects to here and so forth. And then there's also, I think there's another one that like, And then there's Hawaii that's like using I don't know exactly what, but essentially there's like some key pipelines of just like this pipe that these are literally the physical backbones of the internet. And I mean, now we do have like that's the whole point of what Elon Musk is trying to do with like the space internet things, because then we don't have to rely on this as much anymore. But this is generally where most of the ISPs will talk through and reroute all of the traffic. And so can we go kind of physically you can. And I think that was one of the things that happened at one point. Was it like a couple of years ago? Someone decided like, oh, something's going on and we're gonna try and fix it. And they had to dive down and they found like a crack in the ocean or something. But if one of this just like the pipeline bursts or the thing just like stops working, then the entire like communication channel and all of the internet between like NA and the rest of the world will generally go down. That's the internet for you right now. That is not good. That means like if really like if aliens wanted to come in and be like, how do we get rid of the entirety of like the communication channels that everybody relies on Earth, then okay, let's just dive deep down. Or like Godzilla comes out of the ocean and then happens to just come out where this pipeline is. And then you're just like, wow, submarine cable map. Oh, here we go, submarine cable map. Thank you, Code of Progress. Yeah, here we go. Wow. Oh, there you go. You see it. Ba-bam. Ba-bam. Oh wow, yeah, and they've been kind of like increasing it over time, right? But this is it. There you have it. Here's our internet. If someone decides like, these internets, this cable's interesting. What is this? Well, what does this do? This doesn't seem like it belongs here. Which, oh man, I have another story because my brother got a for his like 5th birthday or something, he got this car, like one of those like electric cars, and yeah, I'll get into that later. But anyway, here you go. This is the entirety of the internet, folks. This is how everything's connected. Here's how like Australia is literally connected to here, then to talk to here, and so forth, and Japan's here, and so yeah. If you want to see how the internet's connected, here they are. You can probably actually just go in and count how many there are, and any one of these lines is pretty much like if you want to cut internet to Greenland, there you go. Like this is the single thing. Or Iceland, there's like 4 connections, and so if anyone happens to just be like, I happen to be in the Labrador Sea and I saw this wire, it seemed very suspicious, and so I decided to cut it, then all of a sudden all of Greenland does not have internet. That's not good. How's Santa Claus doing? Santa Claus is up here somewhere, right? Where's the North Pole? Something like here. Maybe this might be Santa Claus. No, that's a C. That's a C network. But yeah, Santa Claus somewhere up here has internet and does that. And so if you're on this, then this is how all the servers talk to each other. And even if your internet uses the satellite, that satellite then gets rerouted and talks to one of these other like ISP provider servers, and that's how it'll then connect to and talk to all the other servers out here in physical space here. And so yeah, we still depend on just very much just on like these wires and things, and that makes things a little scary, but pretty interesting. I mean, this also, these are the big wires. This doesn't include like all the cellular phone things and all the other things too. And the way the cell phone works is so fascinating too, because then you have the cell towers, and the way that like if you go like if you're browsing or like watching Netflix or watching a YouTube video on your cell phone, and then you're like driving at the same time, then like they do this all sorts of other crazy things where they're like, we have to switch you from one cell tower to the next, while still keeping your connection intact. So then like your IP address gets to be kind of like mutable, Is that the way to talk about it? So then like they know, like the servers will still know how to contact and talk to your device properly without being like, oh, it's a new device because it's at a new cell tower. So that becomes another like big technological challenge. Yeah. Please don't use phone while driving. Yeah, but I mean, like, if you're like kids in the back and watching YouTube, then like if every time you go to a new cell tower you're like, oh, I've drove like 10 miles and all of a sudden now my kid's crying it because it doesn't have YouTube anymore. Like, we don't want that, right? And so that's another challenge. Like, all the whole communication and internet challenge stuff is actually really fascinating, but this is pretty cool. And so yeah, this is basically what the internet's built on. Pretty nuts. Is actually really, really nuts. And then we're deciding to build a blockchain and everything else on top of this. The infrastructure is getting upgraded over time, and it's getting there, but it feels very much like the road infrastructures. It's like, here's the highways and freeways, and we're just upgrading things as they go, but the backbones and everything are still kind of set in place. So yeah. All right. I guess we'll go to the blockchain stuff later, but let me catch up on chat because I missed a whole bunch of chats. Yeah, Desabotage and High Pizza Wizard and Khaled, thank you again so much for hanging out. Thank you for being here. Welcome in. Guys, it's so much better to do these on paper. Paper? This is system design. Here you go. Yeah. All right, and let's see. I'm catching up. And Sparky, how are you doing? How's everything? This is quite simplified. Yeah. Yup. Knowledge happens knowledge. Some squirrels and coding and computer talk. Yep. And happy. Good morning again. Good morning. Use the exit top right of the screen. Oh wow. I'm really far behind. Yeah. I have network and communication class this semester, and you're explaining this better than the professor does. Oh really? That's good. It is still very this is still like kind of like the abstract version of it, but it is like I think this gets people started, and so hopefully this makes sense enough that then everyone else can take that and be like, oh, now I see where everything fits into place. That's pretty cool. But yeah, there's just so many random things that people decided is like, this is how it's gonna work. Here's the internet. Like, we're like, all right, 127.0.0.1, yeah, all right, or 2 or 3 or whatever is going to be the local host. It's going to be whatever machine you're in, so then you can't use that address as anything else. But then there's like 192.168. Like, any of those is also going to be your local subnet, like your local internet Wi-Fi network kind of stuff. So then you can connect and contact any of your other devices, like your refrigerator that's connected to your local Wi-Fi. And so somewhere along the way, someone decided like, 192 is a really cool number, and 168, let's use that. Why not? Like, okay. And then there's a whole bunch of other things, like there's other ports. There's other things too, like what is it? 1536 is kind of the top. Wait, maybe 5. I think 6. I can't remember. But 2 to the whatever number is the like 16 or whatever is the number of ports that are available. But then generally anything below, I would say 1,000 is reserved for something critical that your computer's probably doing, so don't use that. Anything above it is probably fine. Like anything like 8,000 and above is totally fine too. And so I think it's more about subnet distribution and division. I don't remember fully. They kind of did, but then at the same time is like, when they were designing it, they definitely weren't thinking about IoT and potentially your own like Wi-Fi connection having potentially hundreds of devices or thousands of devices, and is not great. But it's getting there. They're fixing it. 224 is testing or something. Oh yeah. Oh dang, so many things. Oh, this Atash says, I got a network engineering much more than a decade ago. I didn't touch it, but it's good to see nothing has changed. Yeah. The internet takes a lot of time to change anything, I think. It needs to be sending water over a pipe. You have to set up the pipe every time. And then spraying rooms. My name is Hired. C see you on. Oh, thank you, Informa. Thank you. Is it Wednesday? Oh, Rose says I have to rewatch this fall tomorrow. Oh, yeah, rewatch it. I'll like highlight it and put it on YouTube's or something. That's probably good. I should do more stuff like this. That would probably be really good. Did you see me doing PowerPoint? Oh, PowerPoint. I should have done PowerPoint. Actually, Informa does really cool PowerPoint art. We also had a class on wireless networking, and when you told about Elon's space thingy, you went right. Unreliable, yeah. And wireless, you can get all sorts of other issues where you have like solar flares being like, oh, did you want that bit to be a 0 or a 1? Because we just decided to make it random. and so then they're like, oh. And then every so often, out of like 1 in a million packets, which is like, or like billion packets, which happens all the time. With like so many communication things happening all the time, like billion packets is nothing for the internet, but every so often you get like the random mutation of like solar flares and things, and you get that little bit that changed but that is still valid and gets through all of this and says, oh yeah, like that's a valid packet still with the certificate like encryption and everything. It makes it through and says, oh, this is the little pixel that you wanted. And then all of a sudden people are like, oh, what is this? Why is that pixel green? Is this something wrong with the system? And or like, oh, was there a jump in the prices? Did Tesla skyrocket to $1 million per share all of a sudden? Like, crazy things can happen. That's like just the physics of it too. That's not even talking about like the computer science aspect. It is nuts. Technological things are crazy. So if this is Web 2.0, what's 3.0? Oh yeah, we were gonna do blockchains. So yeah, I mean 1995. I'm not sure what they were thinking about. Yeah, they weren't really. They were just like, let's get something working. And this is all like, it all started from the original like military communication things with like several machines too, right? And somehow it expanded, and they just kind of built these protocols on top of it. And what was it? They started with like Cobalt, and I think it's cool. I don't remember. But it's wild. Pretty neat.